Hello, my name is Nick Ardinger, and this is my presentation for my Cybersecurity Project 1, creating a virtual network for a client. The executive summary, our objective is to upgrade a client's IT system despite limited budget and no physical space for new equipment. Our solution is going to be to implement a virtual machine to replace the need for physical hardware, thereby by reducing costs and space requirements. New components to be virtualized are going to be firewalls, the CEO's PC, the internal web server, the internal DNS server, and Linux machines for cybersecurity tasks. The final step is going to be documenting configuration and establishing a security baseline via an open port scan. To set this network up, we'll first download the virtual box. After installation, we'll add it and configure all the necessary virtual machines within the virtual box. And then finally, we'll confirm network connectivity for all the VMs and resolve any issues encountered. In this screenshot, you can see the virtual box and all the different VMs installed, the web server, the router, DNS server, CEO PC, Kali DMZ, Kali Trusted, and the Kali Untrusted. So testing the network, we're going to go from the CEO's PC virtual machine. We'll use the Firefox browser to test the network connectivity by trying to visit the seclab.net. As you can see in the screenshot, the site won't load, resulting in an error message. So we'll disregard the first suggested cause, of the typing error. And we're going to go with the second, which was a network connection issue. To test this, we're going to use the ping internal DNS and web server from the CEO's PC. And once we're in the CEO's PC, we're going to open the terminal. Begin, we need to open the terminal application on the CEO's PC. We can find it under Applications, Systems, Tools, and then Terminal. And then we're going to try and locate the IP addresses of the DNS and web server. As you can see, where the green circle is on the DNS server, we found it at 10.200.0.11. And then for the web server, the 10.200.0.12. And then we're going to confirm the network connection issue by pinging the DNS server and the web server from the CEO PC. Both of them failed, as you can see on the screenshots below. Exploring the issue further, we're checking the IP address of the CEO's PC to see if it's currently set to 203.0.113.69. As you can see in that screenshot to your right, this IP address is incorrect. The PC needs to be on the trusted network, which is 192.168.0.0/24. To ensure the CEO's PC is recognized by the firewall and other machines, we're going to change the IP address to be within the trusted network range. Resolving the IP address of the CEO PC. So we're going to access the network connection settings from the taskbar icon. We're going to navigate to the VPN connections, configure the VPN. We're going to select Auto F2 and click Edit. Then we're going to go to the IPv4 settings tab to make the necessary changes. And then note also that the IP address, gateway, and DNS server are all incorrect. So what we're going to do is under method, change the setting from manual to automatic DHCP. Note this option assigns IP addresses dynamically. Since our machines use a NAT network adapter, this setting will automatically find and connect to all available machines. Apply the change, entering the appropriate credentials when prompted. So here we're going to test the network connectivity using pings. The initial test failed for the DNS server and the web server because the connection was to Auto F2 was not properly established before the configuration changes. Once we configured the changes, you can see in the third or the far right screenshot, the ping succeeded once the connection was reestablished and we were able to accomplish the goal of connecting to the network. So project questions and answers. So on question one, the answer is a single DMZ was being deployed. Question two, there was no connection to the DNS and web servers after pinging them. To fix this issue, I changed the IP address to the CEO's PC to match the trusted network's IP address. For questions three, four, and five, the OS version, IP address, prefix, default gateway, and DNS server are listed on slides 13, 14, and 15 for the CEO PC, the DNS server, and the web server, and we'll show those shortly after this. Question six, web server open ports and protocols. For the web server 22 through 8180, you'll see these on slide 16 in the screenshot. And question seven, the DNS server open ports and protocols were 22 and 53. You'll also see this on slide 16 of the screenshot. And for question number eight, the username was Jasper and the password was too hard to guess. So details on the CEO PC, you can see the OS version was the CentOS 6.4. This is the correct IP address under the trusted network. The prefix was 24. You can see the default gateway address and the DNS server address as well, based on the screenshots to your right. These are the details on the DNS server. You can see that it's the same OS version, the CentOS 6.4. There's the IP address, the prefix of 29, the default gateway, and the DNS server, and you can see that on the screenshots to your right. And then we have details on the web server. This OS is a Ubuntu 8.04 with an IP address and then the prefix 29. You see the default gateway and then the DNS server address, as you can see on the screenshots to your right. And then for question, I think it was seven and eight, ports for the DNS web server serving and the web server using an Nmap scan and Kali Linux Trusted Virtual Machine. The top ones are going to be the DNS, which is the 22 and the 53 open ports. And then the web server ones are the ones below 21 all the way down to 8180. For the CEO PC, we're going to use FTP to download the social media security policy from the web server. As you can see, we put in the FTP, it connected, then we typed in the name, Jasper, and the password. Um, After that, we put it in the list, and you can see the social media security is in there in the list on the screenshot. Once we did that, we closed it, we exited, and then we hit LS to see the list of everything in there. And at the bottom, you can also see the social media security policy at the bottom. Creating a new user on the web server. So I did sudo add user and I created Jinx. So we added Jinx to the web server, typed in the password, everything was successfully entered in there. Um, Yeah, and as you can see at the bottom, it shows that, yeah, we typed in grep Jinx, and then, it shows it's in the system for the web server. So we added a new user. Protecting the trusted network from the untrusted network. We can prove our trusted network is protected from the untrusted network by using ping tests. Pinging the untrusted network from the trusted network was successful. However, when we attempted to ping the trusted network from the untrusted network, the test failed. This one-way communication confirms that our security controls are currently blocking access from the untrusted network. As you can see in the screenshot below, it says connection refused, letting us know that, yeah, it's blocking access from the untrusted network. And then using the Kali Trusted Linux visual machines and Wireshark, the Wireshark analysis revealed that the FTP transmits credentials in plain text, exposing the username and password, which was Jasper, and then too hard to guess. This security vulnerability requires immediate attention and mitigation for the client. I suggest them to replace the FTP with SFTP or SSH. Both of these offer encrypted connections to protect data and credentials, making them secure replacements for their older and secure methods like FTP. That was my presentation, and I thank you for your time.